Hi, I'm Andrew Betts. I'm a developer relations engineer at Fastly. When we talk about personalization on the web, we're generally referring to using attributes of a user's identity to customize content and make it more relevant for that user. And this is a really important and valuable thing to do. Personalized content is more engaging, it's more interesting, it's more likely to convince the user to come back and use your service or product more often. But personalized content has performance problems at scale. Even if you have an edge network or a CDN like Fastly, which allows you to cache copies of your content on servers all over the world, you might find that requests for personalized content always end up having to go back to your own central infrastructure. And that creates huge load on your servers and long delays for end users. And this is because producing a page that is very specific to a particular person in a particular situation at a particular moment in time it requires inputs that are basically unique to that situation. And you will then find that you can't really use that content ever again. But we can break this problem down into more manageable chunks. This page might, for example, contain attributes of the user, a store, a bunch of different products, a global region, and all of these combine to produce a single page of content. But what if you were to serve all of those pieces of content to the edge separately, cache them separately, store them separately, and look them up separately based on their separate IDs? You can then combine them together into that single complete page of content at the edge and serve it to that user. This can reduce the total possible number of variations from the near infinite to a number that can make caching very feasible. And with edge caching, we get vast improvements in performance as well as much reduced load, and also reducing the bandwidth from origin as well. And the difference can be quite dramatic. Personalization of the edge also benefits from a really useful property of human beings, which is that we don't move around very fast. A user who starts their session connected to one point of presence, like say Frankfurt, is overwhelmingly likely to remain connected to that same point of presence for the duration of their session. Caching is also not the only way that we can store content at the edge. At Fastly, we have several options for things like our KV store, secret store, config store, and these are suitable for content fragments, images, user or session data, metrics, secrets, or anything else that you want to have convenient and fast access to at the edge to personalize the user's experience. Let's consider an e-commerce site like this template. How do we personalize a site like this? Let's look at 3 practical types of personalization and walk through how we can apply them to this site at the edge. Now, if you don't already have a Fastly account, now is a good time to go to fastly.com/signup and get one of those, download our CLI and install that on your local system. Once you've done that, you should have the Fastly command available. So if I switch over here to an editor, I can type Fastly compute init, which will initialize a new computer edge project. And the first important thing here is to choose the language that you're going to write your code in. I'm going to write my code in JavaScript. Once I choose JavaScript, I get given a set of starter kits to choose from. I'm going to choose number 2, the empty starter kit. This is a JavaScript project. We're not opinionated about how you manage your JavaScript dependencies because there's more than one tool available to do that, but I'm going to use npm. So I need to run npm install to install those dependencies myself. We actually only have one source file right now, which is index.js. It sets up an event listener, which is listening to the fetch event. And the first thing I'm going to do here is to create a couple of convenience variables. So I will start with variable called rec, which I will set to the event.request. And you can also, if you wish, create a convenience variable for the URL, which we can set to a URL instance, rec.url. And the other thing we need for personalization is the user's identity. Now, it's beyond the scope of this talk to consider methods of authentication. There's lots of content elsewhere on the Fastly Developer Hub if you want to look into how to do that in a Fastly service. But I am going to assume that I will have some kind of function that will read a cookie and will tell me who the user is. So let's invoke a function called get user from cookies and pass to it the cookie header. And I'm going to implement that function, but I'm just going to return a hard-coded user for now. There we go. All right, the empty starter kit, which is a very minimal starter kit for Computer Edge, actually just returns a completely blank 200 OK response to every request that it receives. So I don't want it to do that. I want to actually send a request to a backend. So I'm going to start by defining a backend response as the result of the fetch call. I can pass the request that we received from the client directly into that fetch call, but I will need to provide the name of a backend I want to use, which I will call content backend. And this is the start of creating connections between my Fastly Computer Edge application and the resources that are available outside of my application within the Fastly platform. Once I've got that backend response, I can use it instead of this hard-coded response. I can just return that backend response directly to the user. The other thing I'm going to do before I send that request to the backend is just modify it slightly to remove some headers. I'm going to remove the accept encoding header. And I'm also going to remove the cookie header. We remove the accept encoding header because if we allow that to be forwarded to the backend may return a compressed response. The second thing is not forwarding the cookie header. Now, we are identifying the user at the edge here. We have the user's identity and we're using that to personalize the response, or we will be. So it's actually a really nice separation of concerns to know for sure that the backend does not know who the user is. So we can guarantee that the content that we're receiving from the backend is not in any way customized for this particular user or this particular request. Okay, so before we run this, we need this content backend to exist. So I'm going to go to the Fastly toml file here and set that up. And I actually have that ready here that I'm going to paste in. So local server provides the configuration for the local server that is going to simulate the Fastly platform, my local machine. Backends is the section of the local server section that sets up all of the backend servers that I want to make available to my application. And here I'm creating one that I'm calling content backend. All right, so I've set that up. I've finished writing my initial set of code. So I'm going to type Fastly compute serve. Oops, Fastly compute serve. So this will compile my JavaScript to WebAssembly. It will spin up an instance of our local testing server, and it will give me a URL that I can use to visit that in a browser. So I'll copy this, switch to a browser, and as you can see, I will just refresh this because it was already open. And there we are. At the moment, we are making a fetch to a backend, we're receiving a response, and we're sending that response directly to the client. What I need is a stream transform, something that can examine the response body as it's being received from the backend, make changes to the content of that body, and pass that body stream to the client. And what's very important at this point is that we don't buffer the response body in the Computer Edge program. Because first of all, if the response body is really large, we might run out of memory. And secondly, it's going to have a huge effect on the performance to the end user. So it's extremely important that any transformations or modifications that you want to make to the response are done in a streaming manner. So let's start by going back to the browser. I'm going to open a new tab and go to the Fastly Developer Hub. And in solutions examples, I can find a whole bunch of code examples. We've got hundreds in here. And I know that I want this one, running a template engine at the edge. So here I can see a JavaScript implementation of a replacer stream, which is a kind of transform stream. that can find textual placeholders in a text-based response body and replace them with something that I can generate at the edge. So this is basically what I want. So I'm going to take a copy of this code and go back to my code. Now, to keep things tidy in my application, I think I'm going to create this as a new file, which I will call replacer stream.js, and I'll paste the code that I got and export that. Now in my main file, I can import it. And I can use it. We can apply this transformation only to HTML. So let's start by defining a variable called const as HTML, which will look at the content type header, or an empty string if the content type header doesn't exist, and checks that it starts with the string text HTML. Okay, so if the response is HTML and it has a body, of course, many responses don't have a body because they are 0 length. So then there will be no body stream. So now we can create a new body stream, set that to be the existing body stream, piped through a new placer stream. For now, I'm just going to define those transforms to be an empty object. Okay, so now I need to create a new response because I've got a body stream, but I need to put that body stream into an HTTP response. I will take the existing backend response and by default assign that to a new variable, which I'm going to call response, meaning the client response. And in this particular case, I'm going to redefine that to be a new response, which takes the new body stream. And we also will need to provide it with some headers. Particularly, we will need to provide the content type, which is text HTML. And we probably also want to provide a cache control header, because if we're personalizing this content, then it's now private. So we don't want anything downstream of the Fastly application to cache this content. Then down here, instead of returning the backend response directly, we'll return our new modified response, which is either going to be a copy of the backend response, or if the backend response is HTML and it has a body stream, then it will be our newly composed response. Great. So now I can go down here, stop my local server and start it again. It will recompile my code, rerun my server. And now if I switch over to the browser, back to my test site here and reload it, it still works. Okay, now we've set up a template engine effectively. And the first thing that comes to mind is login state. So login state is this little bit often in the top right-hand corner of a website like an e-commerce site, which simply tells you who you are, or it provides you with a login or a create account link. If you are logged in, it will likely echo back your name, and it often also provides a link to manage your accounts or to log out and those kinds of things. Often this is solved on the client side. It's quite common for front-end libraries to populate the login state using, say, a React.js component or some other kind of front-end framework. But of course, that information may not be verifiable. They can often cause layout shift if the login state appears after the rest of the page is already rendered. And of course, they can add performance problems to the site. So what's ideal? Well, ideal would be if your backend could serve the page without login state included, but with a placeholder to indicate where it should be rendered. And then the actual verified login state of the current user would be added to the page just before it was served. JSON Web Tokens are really great at carrying stateless session information, like, for example, your name or certain really key properties of your account profile. Using some of that kind of information, we can actually populate login state without necessarily having to use any kind of other backend service or API.
Back in the code, remember, we already have a function here that can turn our cookie into a blob of data about the currently logged in user. And we already have a template engine that can turn data into content inserted into the response stream. So now we just need to connect those two things together to put the login state into the page. So I'm going to create a new file here called templates.js, and I will export an object where I'm going to map my template placeholders to functions that can generate content. Now, I already have on the clipboard some content, bit of a cheat, but you know, the HTML, it doesn't really matter what the HTML is, it will be HTML that suits your particular website. The important thing here is that we are looking for a variable called auth. If it's defined, we assume that the user is logged in, and we're looking for the name property of that object to be defined so we can put it into the page. If it's not there, then the user is not logged in, so we display a login link. Okay, so how do we get access to this authentication data? I'm going to export another function called setAuth, which will take some data, and I'm also going to define up here a map, which I can store that data in. I've lost the export function. Right here. Okay, so then in here I can populate that map with the data that I've passed into this function, and just sort of for symmetry really, I will also define a getAuth function which doesn't need to be exported and will just return the auth value from the map. Okay, and then in my login callback, I can now define a local auth variable to be getAuth. Okay, so now we can take this new templates module and import it into my program. I'm going to import the templates, which is the default export, and also import setAuth, which is a named export from templates. Now this authentication variable here that is the return value of our getUserFromCookies function, up to this point we haven't actually done anything with this, but I'm going to use it now to pass into that setAuth function. I'm going to use the templates here in the replacer stream, and we should find that login state is working. Let's try it. Okay, let's switch to the browser, and so at the moment we don't have anything being displayed here. There is actually a template placeholder here, but it's not being displayed because it's black text on a black background. But similarly to this one here, which we'll get to later on, it's just the word login in double curly brackets. So if I refresh now, and there you go. Hi, Andrew. Look at that. So we've now successfully modified a generic piece of content at the edge to include data that's personal to the current user or session. Next, let's consider the idea of a home store. So for a bricks and mortar business that has stores all over the world, the user is likely interested in where their local store is, whether it's open today, and when it closes. And this is a really nice example of a sort of personalized situational context that would apply to this kind of service. But there's lots of others. You know, let's say the user has an order that's arriving tomorrow, or you're an events business and the user has booked tickets for an event that's happening today. These are all things that are likely to be overwhelmingly the most important thing to put in front of the user when they visit your site. Adhering to the principle of using single identifiers to reduce the address space and allow us to cache this information efficiently, what I'm going to do is make one API request for the full user profile. So this will give me far more information about the user than just their ID and their name. And from that profile, I'm interested in a property called home store, which gives me the ID of the store that this user has saved as their preferred location. Then I'll make a second API request to fetch the full profile data about that store, which will give me properties like the name of the store and its opening hours. Now, we might have millions of users, but we're likely to have only dozens or at most hundreds of stores. So it's very likely that that second API request at the very least is going to be served straight from cache in the local cache at the edge. And then, of course, we also need the page content, which we're already fetching from the content backend. So in templates, I'm going to add some more data functions. So I've added a function called getUser, and I've added a function called getStore. GetUser will, first of all, see whether the user data is already in my request data map, and if so, just return it. If not, it uses the authentication data from the cookie to get the user's ID. It then composes a request to my user's API. I'm using the same backend, so I haven't defined any new backend service, but of course you could use a different backend server for your API requests. I make that request, I parse the JSON, and then set that JSON into my map so that I can remember that user data in case I need it later on. The store function works in exactly the same way, but I'm just hitting the stores API instead of the user API, and I'm using the store ID that is a property of the user profile. So now I should be able to create a new template function, which is called home store. And async, this will be an async function. Of course, it has to be an async function in this case because the utility functions that we're calling in order to get access to that data are themselves asynchronous, and I'm making API calls. So that's why my template functions need to be able to be asynchronous. For the implementation of this function, we are going to invoke the getStore function, which is going to invoke the getUser, which is going to invoke getAuth, and through this chain of calls, we are going to eventually end up with a store profile. If we don't find one, then we can just return an empty string, which means that part of the page just won't get any additional content. If we do manage to get access to a store profile that relates to the current user, we can then figure out what day of the week it is and look up the opening hours for today. Now, this is a pretty simplistic way of doing this. I'd love to see this implementation do things like figure out whether it's a special day today, might be a public holiday, or, for example, the closing time of the store for today may already have passed, in which case we probably want to tell the user when the store opens tomorrow rather than the fact that it's already closed today. But this will do for now, and we can return a lump of HTML here that tells you the name of the store and when it closes today. Okay, so I'm going to save this, restart the server, and reload the page. And there we go, my local store is open today until 9 p.m. Okay, the final example I'm going to implement in this demo is recently viewed. This is a very common feature of e-commerce websites and apps, and it simply shows the user a list of all the products they have most recently looked at. Here it's worth pausing and considering the trade-off we developers have to make between the value of a piece of data and the time and effort it takes to produce it. Raw data is available instantly at the point it's generated or sensed, but it might require filtering, processing, contextualizing, or aggregating with a lot of other data to produce something that is a really useful insight. This is quite well illustrated in this so-called DIKW model that's commonly used in information science. And one of my favorite ways to think about this is in terms of the real-time traffic maps that you get on things like Google Maps. Data would tell you the speed of a current device. Combining many of these data points over time, we learn that a particular device is slowing down. Combining many of these pieces of information from a small geographic area, we can determine that traffic is worsening on a particular highway. And making use of that knowledge, we can determine that a particular device should provide a reroute advisory to the user. And that final level is the wisdom. We often therefore choose to send all the data we collect across a whole system architecture to a central system where we can turn it into knowledge or wisdom. But in many cases, there's significant value in either doing the initial stage of data filtering at the edge, or at the point the data is generated, and then only centralize the aggregation of higher grade information. Or in some cases, even just use the raw data directly at the point where it's generated. In short, if you send raw data back to a global aggregator, only to then have the same client request that same raw data and use it as is, wouldn't it be better to keep that data where it's being generated? Going back to our demo use case, I want to echo back to the user the products that they've recently viewed. That's a great example of using data in a raw form. I don't need to filter it very much, perhaps just to make sure that I only display each product once. And I certainly don't need to aggregate it with any data that I've collected elsewhere. So if I can make use of a data store that's located near the user, like the Fastly KV store, I can keep this entire subsystem really close to the user. All I need to do is record any visits to product pages just by saving the IDs. Then on visits to the home page, I can pull those IDs, fetch the product details from the products API, and use that data to generate a recently viewed page component in HTML. Back in my templates file, I'm going to start by adding one more lookup function, which is getProduct, surprisingly enough. Very similar to the getUser and getStore functions that I've already created. The only difference in this case is I'm going to take an ID. But otherwise it's the same. I'm going to construct an API request, fetch that particular product from the API, parse the JSON, and then set it into my request data map and return it. Now I can add the template function for recently viewed. So I'm going to put that in now, recently viewed. And I will paste that in because it's a decent chunk of HTML. First thing you'll notice here is that I am invoking a class called a KV store, and my editor doesn't like it. And the reason is because I haven't imported it yet. So let's import that from the Fastly SDK. Import KV store from, and you can auto-complete that, so Fastly KV store. And there we go, that's fine, it likes that now. And I'm going to open a store which I've called recently visited. That gives me a handle to that KV store, and I can then fetch objects from it. I'm going to fetch an object called activity and the ID of the current user. If there is an activity entry in there, I will parse it and as JSON, and then see how many items there are in the list. If it's less than 4, then we'll return an empty string because we can't populate. We don't have enough data to populate a full page component. If we have at least 4, then we can start rendering some HTML, and then we get to the point where we need the list of products. We'll take a slice that represents the last 4 products the user viewed, and then for each of those product IDs, we'll invoke the getProduct function that we just created to get the product details, and then use that to populate a little chunk of HTML that will then repeat for each of the products in that list. And that product data is expected to include the image of the product, the ID, the title of the product, and its current price in US dollars. Okay, so this is making use of data that's in the store, but it doesn't actually help us to populate. So we need to do that as well. So that's what I'm going to do next. I'm going to pop back over to my main file and start to record visits to product pages. So in here, just like in my templates file, I will need to import it's a named export, so I want to import the KV store from the KV store. And now we've imported that KV store, we can use it in the request handler. So firstly, I'm going to use a regular expression, and this is where I can make use of that URL variable I defined earlier that we haven't used yet. So the URL is an instance of a URL class, which means I can use the path name property of that to access the path portion of the URL. And then I can use a regular expression to match against that and determine whether I'm on a product page. So product pages on my website, my little demo website, are /product/ and then the number of the product, the ID number. So I can capture that as a capture group in my regex. If we do have a match and the user is logged in, then we can open that KV store, fetch the activity entry, add an item to the list of products that I've recently viewed, and then pop it back in the store. Now, before this will work, I need to do one more thing, and that is to create this KV store. I am opening it here to write to it, and we're opening it in the templates to read from it, but it needs to exist and be provided to my application. So we do that in the Fossy TOML file in the same place where we define the backend. And I just need to write a little bit of extra TOML here to create a KV store called recently visited. And I can also supply some data to populate the store when the server, the test server starts up. So I'm going to populate the store with a value that's listed against my user ID and contains products 1, 2, 3, and 4. So I can save that, restart the server, and we should see a recently viewed component come up straight away. Okay, switch to the browser and reload the page. And there we have our recently viewed, which should be products 1, 2, 3, and 4. Now, if I go to product 5, and there it is, it's a hat, and then back to the home page, my recently viewed now includes the hat. Now, of course, recently viewed is just one example of how you can store and make use of data at the edge. And the KV store is just one example of one of the edge data storage features available in the Fastly platform. Another idea I really like is storing the complex data structures that you need to reconstruct or reverse actions that the user has just taken, so that you can offer a really straightforward undo feature for every action. It's been proven time and time again that people tend to ignore the kind of "are you sure" confirmation dialogues, especially if you pop them up on every action. And having the ability to undo is not only more useful, but also reduces a lot of the fear that users have over taking an action in the first place. So it makes them much more confident in using your service. Storing undo data at the edge avoids cluttering your central data store, reduces latency, and of course also reduces infrastructure costs as well. Now let's quickly just look at some other ideas for how you can personalize websites and apps using edge computing. A really common one is ad insertion. It's a classic example of where many people want to consume the same content, and in the case of live video, often at exactly the same time. But as the broadcaster or the publisher, you want to serve different ads to each user based on their geography, the user's primary language, or their prior activity history, or something like that. Fastly is actually really great at live video. We really aggressively cache and we support request collapsing. So if many millions of people want the same URL at the same time, we're going to collapse all that down to a tiny number of requests to your origin server, possibly even just one. But as soon as you hit an ad break, you don't want your server suddenly overwhelmed because all your player clients now suddenly need different ads. So consider also pre-warming the relevant pops by requesting ad segments ahead of time. A/B testing and feature flagging is another great use case for edge compute and for edge data storage. It's really common to do A/B testing in the front end, but that's often a bit of a performance nightmare. It can create all kinds of edge case bugs, and the worst thing that happens for me, I see it all the time, is it can cause page layout to shift, especially if the page is loading very slowly. And that's a really horrible user experience, and one of Google's top core web vitals that determine ranking preference. So using edge logic, we can map user IDs to experiment or feature buckets. We can determine what flags should be set for a given user on a specific request, and we could modify page responses to include different variants of content, much like we demonstrated earlier with the personalization templates that we used. Things like recommender engines can generate insights based on very large amounts of data that we obtain from lots and lots of users' activity, and that can then be fed back down to the edge, and that could be used to personalize content as well. Increasingly, I think we'll also see edge computing employed to collect, store, and process data in specific regulatory regions. The global internet has pretty limited respect for the boundaries that exist between countries and the legal status of data that's transmitted between them. So we often have to take steps to comply with laws and regulations that exist in the countries in which we operate. So for small sites, it can be a real headache to serve users in a country where you have no infrastructure, because every request and response could be considered a transfer of data in and out of the country. Edge compute networks, having servers in most of the countries that you have users in, are ideally placed to help solve this problem, and at a very minimal cost. Something to think about as we explore more uses for edge computing and the way that edge computing can be used to personalize sites. That's all I have on personalization at the edge for today. Thanks for sticking with me. If you want more information on things you can do with Fastly, head over to developer.fastly.com or join us for a chat on community.fastly.com.